Alright, topic 1.2 is going to be a review on fractional expressions. So basically we're going to talk about fractions. There are going to be four major operations that we're going to talk about. First is going to be in terms of multiplication and division, and then it will be additional and also subtraction. And again, like if you are like good at this already, like there's no point of watching this video, go and proceed to doing the exercise right away. But if you need help with this, then sure, so you continue watching then. So a fraction is reduced to lowest or simplest form when the numerator and denominator contain no common factors. So the main point is that, so when you do the operation, so you have to make sure that the numerator and the denominator contain no common factors. So unless you get this done, so you're still, it is still incomplete. So what is denominator and numerator? So when we have a fractions, so for example, if I have a over b, so what goes on top, a over here, it is called as being the numerator. I don't remember what it's called in Malay. And whatever that is underneath of the fraction, so that is called as being the denominator. Okay, so that is what numerator and denominator means. Okay, so first let's have a look at in the case of multiplication and division. So what we're going to do is we're going to have a look at this example. So I'm pretty sure that you don't need introduction of this. This is something that you have seen before. So the main point is that you have to make sure that top and bottom, they have no more common factors. So number one, so I have 3 minus 2x, and that is over 14x minus 21. So what you're going to do is, first of all, when you have a look in terms of this, you couldn't really tell whether or not they have common factors. So what you ought to do is, you have to factorize the denominator and also the numerator. And for this case, for the top, there's nothing we can do. There's no need to factorize, because here this is a linear factor of 3 minus 2x. And these two constants, they cannot be factorized. So just leave it as being 3 minus 2x. And the denominator, on the other hand, so this two has a common constant between them, which is going to be 7. So I can factor out the 7. And this will end up being 2x minus 3. Okay, so if you notice, so there's a similarity between the two of this. The only difference is that the sign. This one is positive 3, negative 3. This is negative 2. This is plus 2. So what we can do is, I can actually factorize the top by negative, and I'll have a negative of 2x minus 3. Remember, when we have a function, we can change it any way you like, as long as you don't change the value. What do I mean by that? So for example, if you have like 5 plus 1 in your function, so instead of writing that as 5 plus 1, you can also write it as being 3 plus 3, as long as the value does not change. This is 6, and this is still going to be 6. And this one, if I were to expand this, it's still going to be the same. So this is going to be negative 2x, and negative of 3, so that is going to be a plus of 3. All right, so you can change it any way you like, but don't change the value. So check every single time you change the function. And at the bottom, I'll end up with 7 multiplied by 2x minus 3. And then I'm going to simplify this. And so I'm going to end up with actually a function of negative 1 over 7. So notice how the function actually changed, that we can actually simplify from 3 minus 2x over 14x minus 21 to actually negative 1 over 7. Okay, that is the first example. So the second example, I have x cubed minus 27, and that will be over x multiplied by x minus 3. Okay, when I look at 27, straight away in my head, I can tell that this is a number that I can actually put as being a cube. So this can actually be written as x cubed minus 3 cubed, and at the bottom, I'm going to have x multiplied by x minus 3. So now is the time to apply what we have discussed before, and this can actually be simplified by using the formula that we have seen in difference in cubes, and it's a minus. Okay, so when I apply the formula, so this is what I'm going to end up with. So let's put this underneath, and I won't have enough space. So x cubed minus 3 cubed, that actually can be written as, remember the formula, so it's going to be minus, it's going to be a minus, and minus only come once. So the first term is going to be this term square, so I'm going to have x squared plus, so this two being multiplied together, that is going to be 3x plus, and this is 3 squared, so that is going to be a 9. So that is how it looks like. And underneath, there's nothing we have to do, it's already factorized, so x multiplied by x minus 3, and I can actually cancel both of this. And when I simplify it further, I'll end up with x squared plus 3x plus 9, and that is over x. And of course, this function over here, this is going to be irreducible. We cannot reduce it anymore, so therefore it should be left like that. Okay, example number 3. So I have x squared minus 5x plus 6, and that is going to be over a multiplied by x minus 2 plus b multiplied by x minus 2. And if you already get the grasp of the idea already, so probably what you can do is, so try to do it on your own, pause the video for a bit, so get the calculation and check back with my solution. So that would be a good idea as well. Okay, now I'm going to try to factorize the top. I know that the top is actually irreducible. No, it's actually reducible. So you can use your calculator for this. You can verify that you will get 2 real roots. And if I were to do try and error, so this is how it's going to look like. I'm going to have 3 and 2, minus and also a minus. And at the bottom, can I further factorize this? Yes. If you notice, there's a common factor right here, which is going to be x minus 2, which I'm going to factorize. I'm going to bring that out. And here, I'm going to have a plus b. So now I'm going to eyeball and decide if there is anything that I can actually change. Yes. So these two, they are going to cancel each other. So therefore, I'll end up with x minus 3 as the numerator and a plus b as the denominator. For example number 4, so I have 2 fractions that I'm going to multiply. So this is multiplication, the dot. So I have x cubed over 5x squared plus 3x multiplied by 30x plus 18 over 15x squared minus 9x. Remember, when we have multiplication, so the operation is going to be like this. So if I have a over b plus c over d, so when you multiplied, sorry, that's a plus. I don't mean a plus, I mean a multiplication. So what happened is that I have a over b multiplied by c over d. So when we have product in terms of fraction, the numerator is going to be multiplied by the numerator. The denominator is going to be multiplied by the denominator. So here I'm going to have AC over BD. So what you're going to do is when you come across something that looks like this, so the first thing that you do before you start multiplying them is you factorize the fraction individually. So I'm going to have a look at the first fraction. So here at the top, there's nothing I can do about it, but at the bottom I can actually factor out the x. So I'll end up with 5x plus 3. So that goes the first fraction. And the second, I noticed that between these two, the common constant is 6. I'll end up with 5x plus 3. And at the bottom here, I am going to have 3x as being the common factor. So this is going to be 5x minus 3. So now I'm going to have a look at any factors that can actually be cancelled. So if I combine both of this, so this is, so let me cancel first. So remember, the top can only be cancelled with the bottom. So this is 5x plus 3, this is 5x plus 3 as well. And when I cancel, when I cancel this, this is going to be 2. But when I cancel this, this is going to be 1. And this is going to be 2. And this is going to be 1. So now I'm going to multiply the top and the top. So I'll end up with x multiplied by 2. So that is going to be 2x. And at the bottom, I no longer have this 2. And here I'm going to have 5x minus 3. So that will be the simplest form that we can get for example number 4. So example number 5. So now it's going to involve division. So I have x squared minus 64, and that is over x squared minus 9. So divide by x plus 8 over x plus 3. Okay, before I proceed, let's refresh a little bit on your division. For example, let's see if I have A over B, so divide by C over D, remember? So when you wanted to do the division operation, first of all, you have to change this to product. To change to product. Okay, so what I mean by that, so I'm going to have A over B multiplied by, so remember when we change this to product, so this is going to be flipped around. So instead of C over D, so now it's going to be D over C. So that is how it's done when it comes to the case of division of fraction. Okay, so for this case, what happened is that I'm going to have x squared minus 64 over x squared minus 9. And this is going to be x plus 3, and down here it's going to be x squared plus 8. So don't confuse this. So this is not x, this is actually multiplication. Let's put a dot instead so it doesn't confuse you. Now I'm going to start simplifying. So here this is actually x squared minus 8 squared, because x squared is 64, and underneath is x squared minus 3 squared. And when I have a look at that, I can tell right away. So the fact that I can actually use the difference of what do you call that? So this is actually x plus 8, not x squared plus 8. I can actually use the formula for a difference of square, and this is going to be x plus 8. And now I can simplify this further. When I apply the difference in squares for both of this, I'm going to have x plus 8, x minus 8 over, so it's going to be x plus 3, x minus 3. So I'm going to have that multiplied by x plus 3, x plus 8, and I cancel this and this, this and this, and therefore, so the simplest form is going to be x minus 8 over x minus 3. Okay, so that will be for the case of number 5. Now the last one, which is going to be number 6. So I have 3x squared minus 5x minus 2, and that is over s squared plus x plus 1, and being multiplied by x cubed minus 1, and over 4 minus x squared. Okay, so now I'm going to do the same thing. It's going to be the same rule. I'm going to factorize the top. When I factorize the top, okay, the thing is that I would like to warn you. Let me try to factorize this by using calculator. I'll get 3, negative 5, and negative 2. So it will give you negative 2 and negative 1 over 3. And negative 1 over 3. Okay, the roots is going to be 2 and negative 1 over 3. So we know that if it's 2, then at the bottom is going to be x minus 2. If it's 1 over 3, so this is going to be 3x plus 1 equal 0. This is how you get x equal negative 1 over 3. So therefore, this is going to be 3x plus 1. And at the bottom, can I factorize this? No, this is going to be irreducible. You can check that for yourself. And here, I'm going to apply the sum of the difference in cubes. So I'll end up with x minus 1. Then I'm going to have x squared plus x plus 1. And here, okay, so be careful with this. This is actually negative x squared minus 4. Okay, and therefore I'll end up with negative of x plus 2 multiplied by x minus 2. So now let's cancel whatever that is possible. This and this. So is there anything more? I don't think so. That's it. And so therefore the top is going to be 3x plus 1 multiplied by x minus 1. And I'm going to have a negative right there. So it's going to be x plus 2 at the bottom. So that is going to be the simplest form it could be. Right, so now why don't you proceed with the exercise and try to figure out whether you really understand this topic.